Hi guys, today's notes are on 4.7. We're going to be talking about transformations of polynomials. And this is going to seem a little familiar at first because these transformations are still the same as our transformations of quadratics and absolute value that we did in chapters 2 and 1 respectively. So just a quick review, remember that vertical and horizontal translations are when you're adding or subtracting something to either the function or x. So if you're adding to the end of the function, well, maybe not the end, it could be the beginning, but if you're adding to the function itself, right, so this is our parent function, then you are going up or down, depending on if it's positive or negative. If you're changing only the x values, right, so it's inside the parentheses, then this is your horizontal translations, which is left and right, and please remember that these are opposite signs inside, you see that negative. And then reflections are actual negatives that we are multiplying the function by. So either y or x. So if I'm multiplying all of the functions as my y equals, then it's outside the parentheses. If we're multiplying just the x's, it is inside the parentheses. And this is the y-axis for outside, x-axis for inside. Vertical stretches are multiplying the entire function in front. There are no parentheses in this one, or it would be outside. Shrinks are fractions. And horizontal stretches and shrinks, please remember that it's the reciprocal. Okay, so this one I'm going to write opposite, positive, negative, and this one is reciprocal. So if it looks like a fraction, you have to take the reciprocal of 1 over 5, which is 5 over 1, which is a stretch. 6 becomes 1 over 6, which is a shrink. Okay, so let's get started. The first thing I want to do is in this section, please make sure you write a complete sentence to describe the transformation of f represented by g. So this is our parent function. Notice that there are no numbers in this original function, right? So it's starting at 0, 0. So, or centered at 0, 0. So there is a 2 and a 9. 2 in front is a vertical stretch because we're multiplying. So we are going to say the function g of x vertically stretches f of x by a factor of 2 and then translates nine units up, since it's a positive. Okay? So take a moment, try this one, write a full sentence, please. Okay, I'll pause my video so you don't have to watch me write. Okay, check your answers. The function g of x translates f of x 1 unit left and 2 units up. So the next example we're going to do is we're going to take the function g of x to graph it given the transformations from f of x. Now, notice I don't tell you what f of x is, but I do tell you the shape or give you the shape of f of x. So that means my g of x is going to have this same basic shape, but switched a little bit. So let's identify that this is a reflection, and we don't need a sentence here because it doesn't ask you to describe it. This is just for our own purposes. So reflect over the x-axis. Okay, since it's outside, it's reflecting up and down vertically. And then this is a translation 3 right. Okay, I did not write it all out since this is just for our own reference. Okay, so we're going to go 3 to the right. We're starting here. I'm going to go 1, 2, 3. Okay. I'm also going to notice that there are points here and here just so that I know that it's up 1 over 1. Okay, and I'm going to go, instead of up 1 over 1, there's a reflection over the x-axis, so down 1 over 1. And I'm going to make sure that it's a little flat here. It looks like a quartic. Okay. And this is g of x. I'm going to label that. So you try and see. This function looks a little different, but you're going to have this overall up, down, 1, 2, 3, 4. So it's still quartic, just a different quartic function. I would suggest you have points here, okay, and use those to help you sort of figure out what it looks like. I'm going to pause my video, you try it yourself. Okay, so you'll see I widened things out because I started to sketch it and I realized that I made my function too wide. So then I went back and I fixed how wide this is. I don't have an exact value of this x-intercept, but I know that it's less than 1, and I originally went through like an entire 1 away. And then I realized it didn't look quite right. So I would just do a quick eyeball of like how far away is it and sketch. Hopefully you went 1 left and 2 up. Okay. So now let's write a rule for G that represents the indicated transformations for the graph of f. Okay. And now a rule means an equation or a function. Okay, so we're going to be changing this function based on this. So the first thing I'm going to do is identify like what it would look like if I were just to write the function notation. So we know f of x going 1 unit left would be x plus 1. Okay, reflection in the x-axis. That means I'm going to have negative f of x. Okay, and then a vertical stretch by a factor of 2. I'm going to write it over here just so I don't get in the way of this here. That's 2f of x. Okay. So now what we're going to do, this is slightly different than a quadratic because there's 2 x values that you see, but we don't just shift one of the x's, right? The entire function has to shift. And so what this means, f of x plus 1, means I'm going to replace x with x plus 1. So I'm going to take all of my x's here and replace it with x plus 1. So let me show you what I mean. So here are my x's. And everything stays the same except x plus 1 is going to change. I'll have a cubic still. There'll still be minus 6, but then that x becomes x plus 1 again, squared plus 5. Okay. So if it doesn't say to write something in standard form, you do not need to write it in standard form. We'll practice standard form in class in the future. So let's just continue now. Followed by reflection in the x-axis. Well, this negative f of x means I'm going to take a negative or the opposite of everything. So I'm going to reflect, and I know that the whole thing, all of this, is going to be multiplied by a negative. Okay, so I'm just going to like write without writing this whole thing again. So my next line will be negative x plus 1 cubed plus 6x plus 1 squared plus, oh, sorry, not plus, minus 5. Okay, so maybe I'll use red to identify what changed here. So there's now a negative in front. That negative became a positive 6, and that positive became a negative 5. And then vertical stretch is the same idea, right? You take the whole function and you multiply it by 2. So I'm going to take my entire function as of right now, and I'm going to multiply it by 2. And so when I distribute in 1, 2, 3, I will have the negative stays, but there'll be a 2. X plus 1 cubed is not affected. Positive stays, but instead of 6, it's now 12. X plus 1 squared minus 10. Okay, and this, we are writing a rule for G, so this equals G of X. Okay, please box your final answer. And that's what we've got. Let's do another example. So sometimes things look a little different. Okay. So let's do this. If you think you've got this, you are definitely welcome to try yourself, okay? So you can pause the video and do the example 4 and you try, but please check your answers. So let's see, vertical shrink is, let's write it here, 1/3 times f of x. Translation 8 units down is f of x minus 8. And the reflection in the y-axis is this, okay, with a negative inside. So I'm going to take each of these and I'm going to multiply everything by 1/3. Okay. When I multiply by 1/3, that's the same as dividing by 3. So now I have 1 x to the 4th plus 2 x to the 3rd plus 1 x squared plus 4. Okay, so the coefficients are what change. Then I'm going to translate 8 units down, so I'm going to subtract 8. Okay, this is my 8 units down. Let's draw a line since we're subtracting. So I have 1 x to the 4th plus 2x cubed plus 1x squared, and this will become -4. Okay. Reflection in the y-axis means all of my x's are replaced by negative x's. Okay, and this one I can simplify right away because this just looks really wonky. I know that if I have 4 negative x's, it's going to become negative times negative times negative times negative. All cancel, so it'll be just x to the 4th. Nothing changes. 3 negatives do not cancel, right? 2 of them cancel, but 1 of them is becoming negative, so I will have a negative 2x cubed. One of these will become negative x times 1 is negative 1x, and then the 4 does not change. And this equals to g of x. Okay, pause your video here, try it yourself, and then check your answer. Okay, here's your answer check. Just make sure you've got that. Now, let's write a complete sentence to describe the transformations of f represented by g. You're going to write a new function for each transformation to show how your function is changing. This one gets a little bit crazy depending on what you start with. Okay, in the past, say for instance, example 1, when you had to write that sentence, we started with parent functions, which means that we just go from left to right and we describe our transformations. So this time, we're trying to make f of x look like g of x, but as we write transformations, these other numbers, like this +1, is also going to change. So let's take a look at what's happening. Okay, so we know that this 5 needs a negative. Okay, you see how there's like a negative here. So we want to reflect over the x-axis. Yeah? Okay, so the function g of x reflects f of x over the x-axis. So that's our first step. Now, on the side, I'm going to make those changes. So if I reflect over the x-axis, everything gets multiplied by negative, and you do need to simplify at this point, because otherwise I cannot compare 1 to -4, because now I've reflected that +1 and it's on the negative side. So what I really have right now is negative 5x to the 6th plus -1, sorry. Okay. Now I know that I need that -5 to become a -10. So I'm going to reflects over it, vertically stretches, stretches by a factor of 2. Okay, so I'm going to take that whole thing, maybe I'll write it here, times 2. Okay. And that gives me -10x to the 6th minus 2. We're getting closer. Okay, we're going to take our translation. There is no left and right here, but I need to go from nothing to -2. And I know that -2 is a translation to right. Translates 2 units right. So let's write that in. That means I replace my x with x minus 2. Okay, and now we're getting really close. I need to go from -2 down to -4. So, and 2 units down. So then this is minus 2 more to get us to our -10 x minus 2 to the 6th power minus 4. And this was my goal. Seem pretty self-explanatory. Let's check this one though. What happens if things are already translated left and right? That gets a little crazier. And notice here, this function is not in actual vertex form. So we want to take a moment and notice that -1 is not where our vertex is. You have to factor out the negative first. So if I factor out the negative, I have x plus 1, and then that's all to the 4th power minus 3. Okay. And that's really important to note because from -3 to +1 is very different than -3 to -1. Okay. So let's take a moment and notice that the first thing, if this is my goal, I need to get rid of the 2. And how I get rid of the 2 is I'm going to take this whole thing and vertically shrink it, right? I have to shrink by 1/2. So let's do it. So I'm going to take all of this and divide by 2 and 2. So the function g of x vertically shrinks, I'm just going to write off, sorry, f of x by a factor of 1/2. So let's write in what we have. So now we have x minus 3 to the 4th power minus 1/2. Okay. And then I need to go from -3, which is right 3. Oh, no, I need a negative first. Sorry. Right? So I'm going to reflect. Ooh, okay. So let's do our reflection. I need to change that. So I need to reflects over the y-axis. That means I replace my x with -x. Okay, guys, maybe I didn't need to change it, but then your signs would be all wonky, right? And you can't see what's actually happening. So now, notice, we need to factor out the negative again. Okay, and now we can compare what's happening. So I'm starting left 3 and I'm going left 1. So I must be trying to, let's see, subtract 2. And if I subtract 2 in the parentheses, that's a translation. Translates 2 units right, I believe. Yeah, -2 becomes a +2. And from -2 down to -1/2 down to -3 is -2.5, right? To get to a total of -3. And 2.5 units down. Okay? So the important thing you need to remember for your U try 4 and U try 5 is that you need to factor out any horizontal stretch, shrink, or reflection so that your term here has only, in parentheses, x with a coefficient of 1. Okay? Please pause your video here and try it yourself before you check your answers. Okay, here's what I've got. Show that the work is correct by writing your equations here, please. Okay, so I will be checking for this in class to make sure that you understand what you're doing.